All right, and we're live. It's Thursday, June 19th, 2014. Welcome to another Open Roundtable. We have as our guests Zina Roca and Eduardo Lundgren from LifeRay. They're going to talk to us about AlloyUI. Always a fan, since you guys are big users of YUI. And we also have with us Juan DePazzo and Clarence Dion. So you guys can go ahead and start whenever you like. You maybe tell us a little bit about who you are for the folks listening.
Yep. So we did a roundtable a few months ago, and we presented some of the roadmaps we had for AlloyUI project. And this one, I would like to do just a little bit of introduction about AlloyUI for the new guys from the community, and also for new YY team members that were not very familiar with the project before. And then we would like to also go through some of the news we have related to mobile, and also related to the team that's growing, related to
Okay.
Good for our customers to be able to use this new layer. Also, we would like to talk a little bit about some of the tooling we are building on the project that helps development on top of YY and Alloy. So first, let me start screen sharing.
Oh, there you go. So we lost your video for a moment there.
Did you? Okay, let me screen share here.
Also note when you're typing, does it still mute when you type? I believe it does. Is that correct?
Okay. So you guys see my screen?
There's a little delay, so we'll see.
There we go.
Yeah, I'll walk you on.
Okay. All right, so YY, it's a project that we started in 2009, around 2009, on top of YY3 alpha version. And the idea we had was to put together some widgets that were useful for our clients and for our product, which is a LifeRay portal, to be able to reuse them very easily. YY by then had very few widgets, and we were not sure about if the focus of the library was going to be towards this widgets development, or more like robust core, a framework to provide developers to build their own widgets. So then we decided to put some widgets together, and we built this project, which is pretty much the same as a YY model. So any of the features you find
I think we lost your voice there, Eduardo.
From the solution we ended up providing. So we have many features like date picker, time picker, diagram builder, scheduler, and more. Like we have wrappers on AC editor, which is pretty handy in some situations. We have like wrappers for audio, video, buttons, carousel, and many others that you guys are going to see a little bit of them. And we also have started the project in the past. We had me and Nate who started this project, and now we had many people that we hired for that. So here I have a list of contributors. So now we have many nice guys, like we have Zino Rocha, which is helping us a lot with the project and also with the community of Alloy and other related stuff in the company. We also have Bruno Basto, a developer. Ilian Peichev is a very famous face on YY community since the YY2. He's been around for a long time. We also have Enrique Maíra. She used to work in the US, and now she moved back to here, and she's a very good front-end engineer, which is helping a lot, even contributing to YY some patches. We have like Thiago Rocha and many others. So those guys are doing a very good job in the project, and we were able to move forward a lot with the version 3. currently we are on version 2.5, and today we released the version 3.0 PR1, and then I'm gonna go through a little bit for you. So
I think I can show
yeah,
you.
Zeno is gonna start showing a little bit about the news we have, and then I will go back to show you some of the demos and more stuff. Let me put him on.
Okay, guys. So in this preview release, we have some news, and these news are really related about things for mobile responsive stuff and everything. So we almost all our modules are responsive now, so this is a very good thing. We are really concerned about making everything working in mobile and have the best experience possible. Since AlloyUI 2, we have been using Bootstrap, and we didn't have all the widgets covered and all the attributes, and now we do. So this is pretty great too. So everything that you see on Bootstrap now, we also have it inside of AlloyUI. We have new utilities and new widgets that we are going to show you along this talk, and we also switched our build tools. So we used to use Grunt, and now we are using Gulp, and that was a big change for us, and we want to share some of the results with you too.
What made you decide to change from that? That's cool. We'll talk about that.
Yeah, we'll talk about that. But for those that doesn't know what AlloyUI is, I just want to do a little introduction. So AlloyUI is just this set of YY modules. It's built on top of YY, and we are using Bootstrap as our CSS layer and as our markup layer. Just to make it more visual for you, so here I'm in the, let me screen share and show you some of the modules that we have. So this is the website. We have lots of components here, and so these are our UI components. So for example, if you want a model, we have this component for you. It's really straightforward. The API is very simple. And we also have like not only those simple components that we are used to seeing in every UI framework, but we also have things like scheduler, which is much more complex. And you can create events, you can drag the events for the days. Let me come here and at like 6 p.m. can put something like YY Roundtable and create my event. I can change the views and see all my events here, go to the agenda. We also have components like Diagram Builder. This one is using the YY graphics underneath to build all the stuff. So if you are running this on Internet Explorer, for example, we will render this thing using VML and not SVG as we are using here. So we have lots of those really nice UI components that are all built on top of YUI. And one thing that lots of people ask is, why are we using Bootstrap? Because now we have pure CSS. It's a really nice project. You are doing a really great job on it. But we chose Bootstrap because it has much more CSS for widgets, and that's all we are doing right now, right? So AlloyUI is about widgets, and we have lots of utilities too, but it's primarily widgets, and Bootstrap does a great job with styling those widgets like modal, carousel, and everything. And Pure is very nice, but it's more like for grids and forms and other stuff. So just to clarify, because we have receiving this question a lot.
Are we moving back to Eduardo? Oh, there you are.
So do you guys use your own like custom Bootstrap build, or do you guys just use like what's there by default?
Can you hear us?
I think Eduardo is muted.
Okay.
Okay, can you hear me now?
Yes.
So the question was, do you guys use your own custom Bootstrap build, or do you guys just use what's there in Bootstrap by default?
Yeah, we use the default Bootstrap 3 version. So if you download from the website, the CSS, you just plug, and our markups and our widgets is going to generate the correct markup in order to work. And if you don't want Bootstrap, for example, you can just remove the CSS and implement the styles you need in order to cover that markup. So in this way, you are not forced to use Bootstrap. So let's say you use Pure or other library, and then you want to use one or another widget from us. Just make sure you cover the markup standards of like some Bootstrap widget. You are good to go and use our widgets as well. So that's pretty much it for that.
Have you guys thought about doing the same as Bootstrap does to, initialize your widget from markup?
Yeah, that's a good question. We have a plan in the roadmap, which is to do exactly that automatic initialization of the widgets that Bootstrap has. So we first decided to cover all the features Bootstrap had in order to reach that point. So then a few months ago, we started to creating a lot of options and renaming some of our widgets to match with Bootstrap widgets. For example, we used to have a dialog, and now it's called modal, because in Bootstrap it's called modal. So all the options you have on Bootstrap modal, we also have on YY modal, or on AlloyUI modal. And then once we reach this point today with the PR release 3.0, and our next step from before the final version of 3.0 is to also have the data attributes initialization. So in the end, Zen is going to talk a little bit about the another plans we have to cover a second layer of automatic initialization, which is based on web components. So the first one, we will cover data attributes for people who still wants to support browsers without web component or doesn't want to use polyfills. And then we will also try to ship these web components wrappers on top of the widgets. So, yeah.
That sounds great.
Okay, so let me move forward here. One thing that I want to show you guys is how our new components are looking now. So let me show you some of the stuff we have right now. So one thing that happened in this 3.0 with Bootstrap 3 is they allow us to be a lot more mobile friendly. And then we decided also to not only be mobile friendly in the look and feel, but also in the optimizations in the code, not loading code that's not needed, and other things like this. So, for instance, one example is like the carousel component. The carousel component, we used to not be responsive, but now if you like resize your browser, it's responsive, which you can use on your website. But let's say you go to like an iPad. So if you go to an iPad and you try to load the same carousel, we have some class augmentations which are reusable in many other widgets. So that provides responsive abilities, swipe abilities, and also helps you as a widget developer to easily extend your original implementation with them. So in the mobile, for instance, we have a different control for the carousel, which shows here on the bottom, which is easier for interact. And also, if you want to start interacting, you can like swipe. And here we use the scroll view. So then you can swipe your widget, and this is working with touch events. We also have other components that are doing the same thing. For like the date picker, we have a date picker, which in the browser works inside a popover. But if you want to fall back to the native element, here in the browser cannot actually see too much in the native element, but on the mobile, if you go there, date picker, and the same UI, the same interface, the same custom events, and everything are available through here. So if you click here, you can actually use, and your code doesn't change anything because it's all wrapped inside these utilities. So other example is image viewer. Image viewer also reuse part of the utility we mentioned before, which I'm going to show a little bit soon. And this one also on the browser, it looks like this, very simple. No touch events, no extra files being loaded. So when you go to mobile image viewer, it doesn't load some of the previous files you had here, but now it loads some others, for instance, to be able to swipe the images here. So this is also some other change we made, and we refactored performance and other aspects of it. Zeno is going to show a little bit more, some other widgets we have, and then I will go back to show some utilities we provide on the AlloyUI framework, which are not widgets, but they are pretty nice. So Zeno is going to assume now.
Okay. One thing that it needs to be mentioned is that, so in this new version, in this Alloy 3, we moved from Bootstrap 2 to Bootstrap 3. We moved from YY 3.11 to YY 3.17. And so those changes are related to the dependencies that we use. And to fetch these dependencies, we also moved to another solution. So now we are using Bower, and all the dependencies that we have in the project are fetched via Bower. So I'm going to open here my bower.json file. Can you see it?
Yeah, maybe bump the font up a little bit.
Okay. Yeah, so that's basically what we have here. So the true dependency that we have is YY3, and now as you can see, this is the dependencies that we are fetching from our fork. So we have a YY fork because we have lots of patches to do and bug fixes in YY, and we cannot wait for the pull request to get into the master and everything. So we have this fork, and this is a patched version of some bug fixes. Besides that, we have Ace editor, and so Ace builds as one of the dependencies. We have the API docs theme. We have the website just to generate the API docs, and we have a Goop task to fetch all those dependencies. But getting back to the new widgets, as we were saying, there are new widgets that we built just to be compatible with Bootstrap. So widgets like affix, for example. So this one is a widget that we see in Bootstrap, and it's basically a widget that detects the Y position of your browser, and then it just sticks your menu in the page. We also have one that is called Scroll Spy, which you can scroll into your page, and then the menu identifies the anchors and show you these elements being active in the menu. This one is pretty useful too. Other one is.
Did you guys base those on the ones that I published to the gallery?
No. No. Yeah, a little bit. Yeah.
Oh, okay.
A little bit. And this one is not related to Bootstrap, but it's a new component too. Is the color picker.
Oh, wait,
so you can. Oh, sorry. Have I lost? Can you hear me?
I can hear you, but I don't see any video.
Oh, okay.
There you go.
Let me screen share again. Can you hear me? Can you see it now?
I can hear you. Hold on. There you go. It's back.
Okay. Perfect. So this is the color picker component. You can hide these controls or show these controls. You can activate this alpha channel or not. And then you define the color you want to use. You can interact with this palette here. there's also, you can also interact with those different components, right? So we have the popover, and you want to put a color picker inside of popover, you can do that too. So you have this color input. When you click it, you just choose the color you want and start using it. So we have all those modules, and so for those who like Bootstrap and want to have like drop down, affix, scroll spy, so those modules are implemented in jQuery inside of Bootstrap, and now we have re-implemented all of them and all of their attributes inside of YUI as the AlloyUI, inside of the AlloyUI framework.
Okay. Do you guys have any questions about this? Because I will move forward to the utilities and some new other demos.
Now you can go on.
Okay. Right. So some of the things we are also developing on the framework is some utilities, because widget is the main focus of YUI, of AlloyUI. But in order to build them effectively, we need to be able to reuse many stuff. So for example, we are extending the widgets with a model called AUI widget. It's not actually a regular extension. They are a bunch of class augmentations. Let me screen share and show you.
So this is like a mix-in with widget, or?
It's like a mix-in, yeah. This is a class augmentation that we could use the mix-in feature, or we can aggregate in the base.create in order to compose a class. So we have the CSS class
Really
utility, which very small. All those pieces here are very small, and they are, for example, I will show you the popover source code. The popover source code, they are just this, very small as well, like 100 lines of code. And what is this? This is a bunch of class augmentations, like the ones you guys are already familiar with, like widget, modality, widget constraint, position constraint, widget stack. So we created others, like the CSS class, which provides you a CSS class attributes. So then when you instantiate your widget, you can actually specify a CSS class, and then it will put on your bounding box. So let's say I'm instantiating this popover, and then I want to add more classes to this. I just do this. Two are going to be on your bounding box and also on your content box with the correct suffixes. And then that's handy in some cases. Other ones we have that are also used here in the popover are like the positions, align, also the widget toolbar. So what is this? This gives you this ability here. So in the popover, popover, when you are here in the popover, and you can see it aligns like this. This one is since version 2, but if you reduce the size of your window and you open again, not this one, let me show you this one in the tooltip, because I think the configuration is disabled in this one, but the tooltip you can see easily. So let's say here we have those tooltips on the page, and they are like this. So if it doesn't fit on your page, it automatically repositions to the best fit. So then this is our widget extension, which you can use in other parts or other widgets. We have many others, like transition to encapsulate the widget animation. For example, when you show and hide those two tips, the same code that handles this using CSS3, using the transition model from YUI, is the same part which handles the popover animation. So they are the same code. And one thing that we developed for Alloy 3 is this one called widget responsive. This widget responsive, they are we realized that in order to make our widget responsive, we had to repeat many patterns. We have to listen for window resize. We have to make sure our bound box increases based on your screen size, like a fluid layout. and respect the ratio of your widget. For example, in the carousel, if you open the carousel and change your window size, it automatically calculates the ratio for your widgets, for your widget height. So all this code that we realized we were doing a lot repetition, we are abstracted here in those parts. So those are like utilities we have on top of widgets. Going a little farther from the widget world, we also have something like date parser. So YY, now you can parse a date. You can get some date and then you put a mask, and then you can parse the date to be a string. But the opposite way, we don't. So in this UI data type date parser model, we are able to compile. It's very simple, the interface. There is only in the a.y.date.parse method. Now you can pass a pattern and a text, and it gives you back a date object. So it follows all this, the PHP strf time, which is the one YY supports, masks. So you can actually use this to go back and forth. So this is another utility we provide on behind the scenes. We have many others that if you go to the GitHub source code, you can check all of them, and then you can see them. One utility we developed currently, which I had many conversations with Carity, with like other guys from like Eric that developed the y.app and y.view, is the surface one. So what is this surface utility we created? It's an abstraction to handle single page applications. And then why not only use y.app and y.view and the ones YY provide? We started to try to fix these single page application problems in a real world application, which was the LifeRay portal. And the LifeRay portal has many legacy code, many legacy views that we cannot convert them to something that I can share and compile between the server and the client easily. So we had many constraints in order to provide single page application to that kind of app. And then we start researching and thinking, how could we provide some sort of API that can leverage all this? And then we put a lot of good practices together. We saw like other folks are doing this, other frameworks are doing. And we ended up finding a good balance between what I have and what other people are doing and what we believe is useful. And then we created this surface app. So I have here a little bit, I have this presentation from before, which I want just to explain you this one. We had the portal, right? So what's the problem we saw in trying to solve this one? We have this problem, and each part of this portal, of this website, imagine it's just a regular website. It's a surface. That's how we call it, because we saw other folks are calling like this, and we like this way of calling this. And then we also have the screen. So we needed something more than just a PJAX, because PJAX, you pretty much point to a container to load somewhere else. And in our case, we had different parts of the website which needed to be updated. And those parts need to respect a bunch of things, respect a life cycle. They need to respect history, HTML5 history. They need to also handle like scrolling history and many other stuff. So we put all together and we created this life cycle, which is very close to what we have. But what this surface abstraction provides? It provides URL routing. We ended up creating a simpler routing based on regex, which is much powerful than just base URLs, because on old applications, our base paths are not necessarily without query string. So then we can use any regex routing. So we created this layer on top of the surface model. We also handle the AJAX request, which is configurable, so you can extend this one to load the way you want through AJAX or to any other technique. And then we also handle the update URLs through the HTML5 history. And then we have a screen class which handles the rendering of this. So how is that in practice? I will show a little bit soon. And there are many other edge cases that we needed to cover in order to make sure the single page application feels like a native application. For instance, we have to be able to cache the screens, to cache the views we had. We need a fast back. So the user expects when they click backs to be very responsive. They don't want to wait to reload all my surfaces, all my content. We also needed to handle the scrolling in history. It's not only reset the scroll position to 0 or to leave the scroll at wherever it is. We needed actually to be able to, when you click back and forward, you actually reposition the user in the part of the text or part of the website they were before. So we are also handling this inside the surface model. We also had pending navigations because what that means. So we had to, we realized that many of the cases of PJAX solutions or any other Ajax technique that are out there, they load the content, and before, while the content's loading, your page is already waiting for this content. Like they empty the containers and they have this delay for the content loads, then they bring the new content. And then what we realize is that if we handle all this loading behind the scenes, then almost all my surfaces content are loaded. I flip the surface, I render my screen at the same time, that's good. So we also are handling this abstraction, and we also had to like defer code loading. So if your fragment has other resources like scripts and styles, we handle that for you. We need to make sure we also, on an application, we cover search engine optimization. It's very important for a good SPA. We had to be very careful about memory because single page application, this is a problem, and UX feedback. So all those edge cases, we had to put together somehow. So then we created this model on Alloy, which is called Surface App. It's like my app on my UI, augmented with more of those edge cases handling that I mentioned. We have the screen, which is a very simple class which provide life cycles for you. They are all deferred life cycles, so then you can like, any method can return a promise, a YY promise, and then you can load content, you can do animations and transitions, and that's very, very easy to implement a screen. And we have the surfaces, which is like a wrapper around the node or the DOM element we want to update when we finish this. So I recorded this video, which like a page without the surface, so you can notice a lot of repainting is happening. So when you click on the links, the red rectangles means the page are repainting, so it's repainting a lot. So with the surface abstraction, we were able to reduce more the repaint, and this demo is not still perfect. If you try to use the API, you can do even better with the API we provide to just, for instance, repaint the surface 1 or surface 2. So all this abstraction we put together, and then I would like to show you a little bit of it. Sure. And so this is, so let me actually, and then so this is the demo of the surfaces. Mm-hmm. And the one you guys were seeing. And then if you notice, this page here is requesting, for example, if I go to Network tab and click in About, if you see here, the response of this request is the entire page. So why is this? We would like to have levels of single page application abstractions. In this one, we are loading a fragment. So this means your website, the way it is, imagine a static website right now. If I disable SPA here, if I click About and refresh the page, I have the same content. Mm-hmm. And if I click through this navigation, I would like to be able to, my engine, to, even though I do the request of the entire content, because my server is not optimized, it's just a HTML, a static HTML, I would like to be able to only update the parts I needed, like this part or this part based on the route. So when I click here in like about, it brings this. If I click in surface 1, it brings the surface 1 and also the other parts of the page, but it just touches those parts. It also, the lifecycle can handle like external links with hash. So if I have a hash, Surface knows this is a hash screen, doesn't do anything. And let's see how it works. It's very low level now, but you can actually create abstractions on top of this. So in order to instantiate your app, so you have the Surface app model, which you say link selector, so I'm going to intercept all my anchors on the page. When I click on those anchors from the base path demo surface, I can actually listen for those events, and then I can add screen routes. So for example, if I add /dummy, I can point to a screen. If I go to about, I can go to another screen. If I go to these rejects, which is a much complex routing, you can route whatever you want. You can do any other screen you want. You can actually do also dynamic routing based on functions. So you have all these possibilities when you register routes, and then you also register your surface. So it's pretty much two things you need to do. Three things: instantiate the app, register the routes, point to a screen, and also remember to tell the app what parts of your page you want to do. So surfaces, you can point to a surface instance or the ID of the DOM element, like this. So for example, I have header, nav, info, surface 1 and 2. So if I inspect this page, you can see that I have here on my page let me show you this one. So we have the header, which is the header ID. So this part is a surface. We also have the, let me open this one, surface 1 and surface 2. So it's pretty easy. You just map the IDs of the parts of the page are most likely to be updated. And then based on this surface app handles all for you. You can create your own screens. For example, dummy screen. Let's say you want to implement a screen that does nothing. You can extend the base screen, which is very dumb, doesn't do anything. And then you implement this content, get surface content, and it will pass the IDs you registered. And then you can say, when it's surface 1, return surface 1 content. When surface 2 content. And very simple, because this is the basic example. And then you can also say the title of your page. So the screen is responsible of painting your page. You can also have other screens, like a home screen for the home path. When you say /home, it's rendered by this screen. And this screen, you can extend from screen, or you can extend from HTML screen. This screen is a default screen we created to handle HTML fragments. So basically, let's say you have an old website and you want to make this website single page application. Currently with this model, you don't need to change any of your server side. You just need to register your surfaces and use a HTML screen instance, and this model takes care for you. And you can say it's cacheable or not, right? So once you have all your screens, your app set up, and your route set up, you go to the and start navigating. Like surface 1, it matches with a route. It only updates what is needed from the surfaces. And then it's pretty fast because of this ability. We applied that to LifeRay portal, and the results were impressive. We were able to optimize a lot. If I show you some numbers here. So this is one example of how many we optimized, even though we are bringing the entire content on this legacy application. When you request, the fact that you just inject into the DOM what you need for that specific route, it saves a lot of extra requests. So for instance, let's say you want to load one part of your page which has 3 scripts inside that part, inside that fragment. It only loads the 3 scripts. It doesn't load the header script, it doesn't load the footer scripts and style sheets, and this is a lot of savings. So we compare that, and it's very good, the results we had. And So we are excited about this model because, so this is a dummy screen, right? Surface 1, 2. We are excited about this model because we have an infrastructure which handles all the edge cases for us, and we can now, on top of this, which is it's not very complex, but it's very verbose for you to use. So
Right.
we want to, on top of this, create other screens. We want to create the same way we created the HTML screen. We want to create a, let's say, I don't know, template screen that handles handlebars or mustache. And then we want to create other things that out of the box helps you to do what you want. And this is powerful because it also handles the edge cases. One thing that I would like to show is like the real quick.
Before you go,
The scroll stuff.
hold on, I have one question.
Go ahead.
So, quick question.
Yes.
So, a lot of the stuff that you're showing, it's like a lot of new functionality and stuff. Do you have like tutorials, or like how do your users take advantage of the features that you listed?
Yes, that's something we are going to talk a little soon because we are working on the new website for Alloy 3 with new layout, new design, and also we are working on documentation. So we have API docs for all these models, and in this new website we're going to have demos and tutorials explaining all these pieces with a bunch of details. Then you copy and paste and use. So it's going to be there when we release the final 3.0 version.
Okay.
Okay, so one change that I'm going to do here is I'm going to, let me just put inside this. This is just some templates I use for the demo, but let's, inside this surface, what is this? Okay, here I'm going to put like a bunch of texts just to put this one, just to have a scroll. I want to show you guys like the history.
Okay.
So yeah, it's compiled. So if I refresh my page, is there something happening here? Let me take it out. Weird, there's something. Okay, now I have it.
Okay.
Okay, so let me go back. Sorry about that. Okay, so I have some scrolling here. So let's say you are in a page and then you scroll a little bit and then you read like surface 2. When you click here, we go back, they scroll to this position. Then you keep navigating. So you go here and click dummy link. So scroll is the bottom. So when you click back, the user expects the scroll to go back to the position they were before, like this. Oops. So let me move forward. So if I go back and forward, let me actually navigate more. It's easier to see when you have like 3 pages. So let's say this one, I navigate to 3 pages. So when I go back, I want my scroll to remember the position it was before. So
Right.
all this handling stuff, this is being done by this abstraction. So it's pretty nice. You can create like apps, very powerful apps like screen.yahoo.com and things like this. And we are going to put some tutorials around for you to understand a little more. And yeah, that's it for these utilities demo. We have many others. We also I even talked to Juan about this. We also have a cancelable promises, which is another utility. We extended the promises you guys have and created this AUI promise, which we pretty much provide very few stuff. We provide like then always, some utility methods, then catch. We had to provide then catch because of some browsers that have some problems with the catch word. Cancelable promises, what this provides is the ability of reject a promise. Let's say you have a promise with a chain. So if you have like a file which is a JavaScript, and you have like promise1.then, you do something else, right? So if you have these kind of things, in order to cancel the entire chain, you have to throw the error from here to here, so you have to do all that. But with this, you can just say, like, let's say I consider on the SPA is a cancelable promise. And then I can say just request.cancel if they link, and then it goes through all the promise chains, rejecting this promise, and this promise with a cancelable promise error. So we had to implement this for simplifying some of the SPA stuff. I still need to align with Juan about the ideas he has about it, but in the end we put here on Alloy. So we have many other utilities like this. So Zeno is going to talk a little more about the group and the test we have, and then I want to show you guys something we are also working for building tools, which we are doing some changes on Shifter, and in order to use more the Streams API from the new Node versions, and the results are pretty amazing. So we are kind of excited to put this project out, and then we are going to show you a prototype of it, and then get the feedback from you guys if it makes sense, if it doesn't make sense, and we can see how we can align this with Shifter, because it's pretty good results. I will let Zeno give you a little bit of these details.
Okay.
Okay, guys. So as we said before, we used to use Grunt, and now we moved all our build tools to Gulp. And the reason why is basically because Gulp is based on I/O operations, and Gulp is based on streams. And when you compare those stuff, I/O is much more expensive. I/O operations are much more expensive when compared to in-memory operations. So it's pretty. If you're used to Unix pipes, it's pretty much what happens in Gulp. You're always doing pipe operations. You put some data in, and you output something. And I want to show you some of the tasks here. Let me just screen my share with you. So as I said before, one thing that we are using now is Bower to fetch our dependencies. So if I type gulp init, what it's going to do is basically run Bower install. And so it's just a wrapper for the Bower install command. It will download all the dependencies if there are new dependencies. In this case, all the dependencies were already loaded, so we didn't need to fetch them. We are bringing all the modules from YUI, moving to our build folder, and then replacing those versions that we have there. And now we have everything set up for other tasks. Now that we have this, we can build our project, we can watch any changes and everything. So let me run here gulp watch. So now we are watching for any file changes. And if I go, let's say, so I'm working in the alert component, for example. And I make some changes to the alert component. So we are running Shifter behind everything. So it was really fast. We detected this file change using Gulp. We're not using Shifter watch here. So we are using Shifter just to build everything. But in this case, Gulp is taking care of watching those file changes. When we have this file change in the JS file, we build it. And as you can see, it's just the alert file. It's not all the other files are building again. It was pretty fast, less than 1 second. But one thing that we notice is that sometimes you are developing your widget, you're building your YY modules, and you make some changes into the meta files. So let's say I want to make some changes here. I don't want to require a widget anymore. I want to require any other stuff. So you make this change, and then you need to go to the loader files and rebuild it. So in our case, when you save this file here, so we detect this change to the meta JSON file, and we rebuild the base files, and all you need the exec and post-exec scripts, just to make sure that all those the files are going to be updated, and the developer doesn't need to go there and do it himself. We also wrap any other stuff. Other stuff like APIs. So we are using YYDoc, so we can wrap the YYDoc watch command. So those are the things that, so we are using Gulp, and we are wrapping those commands like bower, shifter, YYDoc, and ones that Eduardo will show now. But we are also working in new tasks and those tasks that are going to be much more fast. But this change already made a big decision, a big difference for us. And Eduardo will show you a little bit more about the tasks that we are doing using Yogi and using Yeti.
Okay, and one task that we also have here on Alloy is the goop test. So if you run goop test, it also invokes the Yogi behind the scenes, and then it starts all the stuff we have from Yogi. And this is also good to mention that we are covering a lot. We are growing the number of tests we have. We are trying to improve. Many of them are still not very good, still like very few numbers, but the ones we have, the coverage is up to 80%. So we are trying to do that for the project. So we also have the Goop tasks wrapping the Yogi, and also we can run Yogi over some server farm to test remotely, not on Phantom.js. So this is all set up here. And one thing that we started doing was, when we started Gup, was that we realized that when we run, for example, if you run Gup, build AUI. I just want to build the AUI models. If I run this command, Gup is very fast, it's stream-based. Shifter is also based on streams in the most part, but many parts of the project could be optimized to use the best of the new APIs Node.js provides. And then we realized we had this bottleneck. We had the Shifter, even though Shifter is very fast, it's an amazing project. We had this bottleneck because we don't use the power of the streams as we can. And then we thought, maybe how much effort is to rewrite or try to contribute to Shifter. And then we took a look in the code. I saw that Cardi is doing a good job, like fixing some bugs, and other guys as well. And then we thought about doing that in there, but it required a lot of changes on the project. So we ended up writing a prototype of a different builder project, which is compatible with Shifter. So its backward compatibility is good. So you can build YY or can build Alloy with it. And it actually uses the modules that are more efficient. So for example, I built AlloyUI here in 47 seconds. So why 47 seconds? Because of those bottlenecks I mentioned, that Shifter needs to adapt to the new APIs existing on Node. So I created a demo with Goop. I called build streams for testing. So, and this is pretty simple. So before I run this command, I'm gonna show you how it looks. So I have here this project called Goop YY. So let me actually open here and show you this. So in your Goop file, it's very easy. We have this YY model that you can use even on Shifter or Grunt. You can use in anything, not necessarily on Goop, because inside this model YY, you only have streams API. It's not tied to Goop APIs. So then you register your build task. Your build task is very simple. Use Goop source, the files. So it's nothing more than a glob stream, which is a model you can use in any Node.js model.
Right.
Then you pipe to the YY setup. What this setup does, basically this setup explodes your configuration, because a model on YY, let's say the model calendar. Calendar builds a lot of other models. It explodes them all. So this setup handle the build.json stream that you want to build, and grabs the JavaScript, CSS, and configuration you need as a file streams. So it doesn't do any operation in the hard disk. And then you call build. So this build is responsible for minifying, creating the bug files, creating also the wrapping the file with the y.add sandbox. And then after you finish all these operations, you write to the disk using kubedest. So it's pretty simple, pretty straightforward, and then we're very impressed with the results with it. So let me show you something here. So you saw before the build UI took 47 seconds, right? And then I'm going to go to Alloy project and delete the build folder. The build folder, for example, AUI, let's say go to AUI affix, right? So affix has all these files. Affix here has the minified version and everything. So I'm going to delete this folder, and I will run the build stream task, and it's building all the models we need on Alloy, and it took 3.40 seconds. So it's like amazing performance. And then the build folder, it's here. So AUI affix. I deleted the folder, now it's back, and what it is, affix. And here I have the minified version of affix and the expanded version with all the dependencies, all the meta JSON information. The debug file and the coverage I disabled for now. And then, because it's not covered yet, but I believe after I generated the coverage, it's not going to be 3 seconds. It's going to be around 8 seconds or 10 seconds, but still it's a big gain. So it's pretty amazing. So we are trying to put all the backward compatibility with Goop. And inside this project, I'm using many things that Goop uses. So it's not doing, for example, let me open here the YY.
Sorry, quick question.
Yes.
Have you published this Goop YY thing?
Not yet, it's local. I'm gonna publish. The reason I'm showing to you guys is because we would like to listen feedbacks like how do we handle that? Should we reuse this streams model inside Shifter? Should we create a separate builder project? The reason I didn't publish it yet is because we have the YY builder from the past, which is ant-based. So it's still around, even though it's deprecated. We have Shifter, we have Yogi, we have all those models, and if I publish this with, I don't know, YY build name, it's going to confuse people more than help. So I would like to align with you guys first, and then we think about this. And then this code is pretty small. So the code is pretty much this file, and I have model. I created a model class which wraps the model. So you have like the full type JavaScript, and then you have like name, config, files, and you have like some getters and setters. Very, very simple, pure JavaScript. It's just a helper for me to go through the code. I have a model registry, which is a abstraction on top of, it's to register my models when I build, and then I access the models I am building to entire code. And then this YY model, you can see here, I don't rely on anything on Goop. It's just model files. I have the Goop filter, but this Goop filter I can use directly from, you can use this Goop filter from all the Node.js projects, or I can use directly the stream filter, which is where Goop filter builds on top of it. And then here I have the setup, which I explode the streams, and then I build it. When I build, I wrap the files and I compress the files. So it's pretty small. It's the file. It's not yet covered. So here I have the templates. I have some private utilities. So I can publish this code for you guys. Take a look after. But that's pretty much it. So this is a very small one that we can very quickly reuse in other projects like Shifter. So this is something we are excited about, that it's improving a lot. And if you do the watch, the Goop watch, using this, for example, to rebuild, for example, the timer, AUI timer, it takes 15 milliseconds. So it's pretty much instant. So you don't have all the headaches of waiting to build many files or waiting watch to take 5 seconds to update your build folder, and then you have to refresh your browser. So we are trying to solve these small problems we have right now. And yeah, so that's what we are doing for tooling together with Goop.
That's really good, really good. I'd love to take a look at the code and compare it to stuff that we've been working on.
Okay, sounds good. I tried to build over YY code and today, and I noticed that the build JSON you guys have has a very loose contract. Some of them has submodels to define the model. Some of them, the models are mapped on the road, and others, they have plugins. So it's kind of a mess, the number of things. And then what I want to do here, because I only support one kind of build configuration now. So I'm going to normalize the build, but this should be easy. I'm going to normalize. So if you go to my test here, let's say I have this build. Let me show you. I only support like this right now, which is the one that is documented on Shifter website, which is name and builds. But this should be okay. I'm going to normalize the ones that you guys have, and then I will be able to build YY as well, not only Alloy. So as soon as I have this, I can ping you, Juan, and show you what we have.
Yeah, definitely. So Shifter has been having some trouble lately. Cardi has been fixing a few issues that were causing trouble for us, and I think we are all very much aware that both Shifter and Yogi are hard to deal with if you want to dive into the source code. And I agree that maybe adding a new tool might be confusing, especially since we want to move away from YY specific modules, and we're investing time in checking if ES6 can help us, get away from this awkward syntax that we have. And so if we could eventually replace Shifter with this, I think it would be awesome.
That sounds good. I will ping you after, Juan, for us to align some ideas how we handle that.
Sure, yeah.
Okay, I think for me it's pretty much it, guys. There is only one quick news, which is the new website, which is then is going to show the mockups, and just to give a preview.
That's good.
Okay. Yeah, so we just wanted to share some of the next steps. Earlier today, we released this preview release, and it was great. Lots of these things that we showed to you today, like these new modules, new widgets, new utilities, all those Bootstrap support. And for the next steps, we are going to release a new website, and this is how it looks now. It's just a mock-up, it's not implemented yet and everything. But it's something that we want to improve for the community, and we are thinking about how to make it even easier for everybody to use and to interact, and use AlloyUI and use YY in an easier way. And yeah, this is something that we are really excited. And one next step that we are also looking forward to is web components. We have been working with web components for a while now, since last year. We created customelements.io. It was a project that it was mostly born here inside of LifeRay before a talk that we were going to give, that we gave last year. So we created this project. Is now the most used web components gallery. It has almost 300 elements. And recently, we also launched webcomponents.org, which was this initiative along with Google, Mozilla, Opera, and all those guys from these companies, and LifeRay. So we built this project to document best practice around web components. How can framework authors like Alloy or YY or jQuery, any of those framework authors can discuss the best practice about web components. So we just wanted to give you this idea that we are studying web components a lot. We are trying to figure out what's the best way to implement web components inside of YY and inside of AlloyUI. It's a big challenge, but I think we are getting there, and I think maybe in the future we're going to have this feature inside of the core.
So are you basically writing custom elements like AUI, carousel, or AUI?
That's the idea. Yeah, that's the idea.
Cool. So yeah, so that way it's pretty clear that you're using the AlloyUI framework underneath. Okay. I think that's a good direction to take. Considering the whole, how big our code base is and our problems with, getting these widgets out to people and having people discover them.
Yes. So one thing, Juan, that we realized, especially after Bootstrap, they have many markups that you have to write yourself in order to be able to HTML parse from your widget. And then the idea also is to make this work simpler, because you can just type your tag. We already print out your markup styled, which is good for progressive enhancement. And then we decorate your markup with the widget. So this is something we want to provide to the web components and save all this. The data attributes that you asked me in the beginning, it's going to be very good as well. But the developer still needs to type and write the markup in order to have the functionality rendered. So that's another point of the components.
Yeah, totally. So, right. So in the future, instead of using data attributes, you would use a custom element with custom attributes, right?
Yes.
Yeah. Yeah. I really like the direction. I'd love to help as much as I can.
Yep.
And
thank you, guys.
So one thing that I wanted to ask you guys, you said, so basically you have a fork of YUI and you've been having trouble getting your patches in, at the speed that you need for your business, which makes a lot of sense. So the question is, I know Andrew has been working on this. I think it will be ideal if you guys could have committer status and just send the pull request, and if no one gives you an answer in 72 hours, just merge your patches and fixes.
We're working to help propose them to become committers, Eduardo and potentially someone else. Yeah.
Yeah, I think at this point, considering how much AlloyUI has grown, we should definitely consider the committer status is usually earned by by contributing to the library, but I think you guys have contributed quite a bit, just maybe in your own project, but it's so related that I think we can consider that as part of the YUI core project.
That's definitely a good idea. I'll bring it up with folks that we're talking about. Yeah, I think that you're right. I mean, up to now we've been just looking at like commits and PRs, but I think that the body of knowledge in the LifeRay library would definitely be a good qualification, especially all the things you're modifying and augmenting, and things like the surface and stuff like that. So.
That's cool. Yeah, we had a meeting, like Andrew said, Juan, and we are willing to help, and let's see how it end up with.
I think ideally you should have the freedom to if you see something that's broken, just go and fix it within reason. Yeah.
I think it's coming. Totally. I think we're about out of time for today, and maybe getting kicked out of the room soon. So, was there any other questions or anything else before we close up?
Not on my side. If you guys want to talk about anything from modules, web components, and how to move this forward, just you can find me on Twitter or Hangouts or whatever.
Yeah, I was also wanted you to. I know you were looking at the Surface demos you had. It reminded me a lot of React.js. I don't know if you've looked at that. Also, as a potential view aspect, the view part, because it also only modifies the parts of the DOM that need to be changed.
Yes.
Yeah, it's also something that a lot of guys in the community have been asking for, which is nested apps. So instead of doing nested apps, you came up with a new abstraction that everything works a little better. Yeah, I like it.
Yeah, I would like to show you like this in LifeRay before, but I had some trouble here locally. But the results are very impressive. Like when you apply to a legacy app, you don't change any backend, and it's a lot faster, and even repainting and stuff. So I can probably share that later to Twitter. So keep watching. I'll see what I can share later with Zeno.
Sounds great.
Cool, yeah.
All right, thanks.
Thank you very much, guys. Thank you very much for the opportunity, and catch you guys offline.
Yeah, definitely.
Yeah.
Thanks again, everybody. We'll see you later.
Thank you.
Okay.
Bye bye.